All right, let me just make sure all my settings are up to par since this is a little bit unscheduled, but there's a few reasons why I thought it would be important to have a session today. All right, here. All right, well, let me know if there are any major audiovisual issues, but it looks like we're otherwise good to go. I wanted to talk today primarily, or at least start out the conversation by discussing the what appears to be a pretty catastrophic wildland-urban interface wildfire event in Hawaii on the island of Maui late yesterday and apparently into the overnight hours last night. Not a place that people necessarily associate with very large or risk of severe fires, but perhaps that shouldn't be people's default assumption. We can talk about that a little bit. I want to talk a little bit about what happened, with the caveat that it's still an unfolding disaster, and so information will likely come to light later. Similar to how many recent Western U.S. wildfire disasters have been uncertain in terms of their details in the early hours. Probably even more so in this case because it sounds like communications have been completely cut off from the entire western half of the island where the fires occurred and where most people in the settlements there actually live on the island of Maui. So, with the caveat that information is scarce, I want to talk about physically what happened, parallels with catastrophic fire events that we've seen in other regions, very different ecosystems and climates, but ultimately a similar disaster, unfortunately, that we've seen time and time again. What different factors at play in terms of how long-term trends have affected the risk of things like this. And then at the end, I want to shift gears a bit and talk or revisit the impacts of the Hunga-Tonga volcanic eruption back last year, and also of a rather sudden decrease in the level of aerosol pollution coming from ocean-going ships over the last few years, and the effect that that's having on climate or not. And so I wanted to talk a little bit about that because there's a lot of misinformation swirling, and I did have a long session where I talked about that earlier in the summer, but there's new evidence, and I wanted to talk a little bit more about it today. I may have, by the way, an additional live session in the days to come to talk about a heat wave in California or some similar things, so we will see. But I wanted to jump on today because I know there are some journalists who are either watching this now or will watch it after it's uploaded, who are looking for perspectives on what is unfolding in Maui and also what is unfolding in terms of the emerging scientific understanding of the effects of this very unusual volcanic eruption that occurred last year on the exceptional extreme heat events of this summer and also of that marine ship aerosol question too. So let's start with Maui and what has happened, and I'll quickly summarize my understanding of what has happened so far. Is there have been multiple large and fast-moving wildfires, large in relative terms, of course, on the order of a few thousand acres, as far as I know. Although again, this is a relatively small island, so these are large fires, certainly in that context. Have burned from east to west, primarily along east to west oriented axes, mainly on the island of Maui, but there's also at least one major fire on the big island of Hawaii. That one, to my knowledge, hasn't caused big problems yet. But at least one of the major fires on Maui, unfortunately, appears to have become a catastrophic wildland-urban interface firestorm. I think at this point it's safe to say, based on news reports, footage, and Earth-observing satellite imagery, they all corroborate what unfortunately looks like will be another really bad disaster that is fueled by a wildfire quickly moving into a highly populated area and then becoming essentially an urban conflagration where it burns structure to structure. This particular fire occurred under unusually dry and windy conditions. There is antecedent drought. It has been warmer and drier than average. What else is new? On the leeward side, so not the windward side of the southern Hawaiian Islands, but on the dry side, that is rain shadowed by the mountains of the interior of the island. So in Hawaii, the wet areas tend to be the eastern sides of the islands all the way up the mountain slopes, and the dry sides tend to be the western side of the islands because of prevailing east to west winds. So it's actually not dissimilar from what happens on the eastern side of the Sierra Nevada. The difference being, in California, the prevailing wet season winds are from west to east, so it rains at the coast and on the west slopes of the mountains. The rain shadows on the east side in the Great Basin in Nevada. In Hawaii, this occurs on a slightly smaller scale, but is similarly dramatic, where the eastern sides of islands that bear the brunt of moisture-bearing Pacific storms and trade wind showers transitions to a much drier condition on the west side of these islands. So the western side of many of the Hawaiian Islands receive, in some cases, multiple times less precipitation than the eastern slope. So it's quite a dramatic difference. That means that ecosystems on the western slopes are often brushy and scrubland more than lush forests. So you can get lush subtropical rainforest, for example, near Hilo on the east side of the Big Island, and you're in quite a relatively dry and more sparsely vegetated area, certainly a drier region on the Kona side of the Big Island. Similar situation in Maui. And so the fires that we're seeing are on the dry side, on the leeward side of the islands, where there is a lot of dry brush this time of year. This is the dry season on the leeward side of the islands, and also it is unusually dry and warm even for the dry season right now. So there were antecedent moderate to severe drought conditions on the west side of Maui where these fires have occurred. So that is a relevant piece of the story. Dry brush that's even drier than usual was set the stage, and then the catalyst appears to be a very familiar story from California. The ignition source is not yet been confirmed, but there are rumors that very strong winds blew a power line down or blew branches into power lines, which ignited the brush. We've seen that a lot in California, and winds were indeed unusually strong. In fact, the reason for these strong downsloping winds, again, does this sound familiar, was the combination of unusually high pressure to the north of Hawaii and then a fairly strong hurricane a few hundred miles to the south of Hawaii. So ironically, it is very possible that the presence of a hurricane relatively nearby, but not close enough to produce any precipitation, helped amplify a downslope windstorm on the Big Island and in Maui that certainly contributed to the extreme fire spread. It produced drying of the air mass, much as you get during a Santa Ana windstorm or a sundowner wind event in Southern California. It dried out the air as it compressed and heated up as it descended down the topography of the mountains at the interior of the island. The winds accelerated toward the coast, and unfortunately it appears this fire ignited just upwind of town and essentially appears to have burned many or even most structures in certain, at least one or two different towns on the west side of Maui. And these are relatively significant settlements of 10,000 or more people each. So this is a major disaster. The true human toll is untold, but unfortunately it sounds like there have been multiple fatalities already confirmed and quite a lot of pretty terrible sounding burn injuries. So this is not a case where everybody got out in time, which unfortunately is not particularly familiar in the last decade or so. But people literally running for their lives barefoot down the street and jumping in the ocean. That's how fast the fire spread down the slopes and into town. In other cases, people caught either in traffic jams or literally had their way blocked by flaming debris that was falling out of the sky. Again, these look like disaster movie scenes, but these are real-world events that just took place in Hawaii on the island of Maui. So this is clearly an unfolding disaster. Also, telecommunications apparently have been completely cut off from the western half of Maui where this event occurred. So this is not a case where no news is good news at all. It sounds like there is going to be a lot more news to come, but it does look like this was a hugely destructive fire. Structural losses certainly in the hundreds, maybe in the thousands. Some loss of life, at least, potentially significant. It may rise. So I don't want to speculate too much about the numbers, but the point is, this was a classic, unfortunately, wild and urban interface fire where there was a vegetation fire, a wildfire, but it moved into an urban area and started burning structure to structure. In fact, it even started burning vegetation right along the beach and appeared to even start burning boats in the bay. The wind was so strong, the ember storm brought embers all the way onto the wooden hulls of boats out. I'm extrapolating a little bit, but from some of the footage, there are boats well away from docks and the shorefront that were burning, and I'm guessing that's probably what happened as these 60-mile-an-hour winds pushed embers offshore, which reached the boats that were moored away from the coastline. So really extraordinary event. A lot of folks are expressing surprise that this occurred in Hawaii, but the Hawaiian Islands actually do have a long fire history, both in the most recent century and also prior to that with indigenous and cultural burning. Certainly there are ecosystems that are fire prone, especially on the dry sides of many of the Hawaiian Islands, particularly the big island of Hawaii and Maui, but also to a lesser extent other islands. Prior to 100 or so years ago, most of these fires were indigenous and cultural fires. More recently, these fires are still, vast majority are human caused, as is the case in California, mainly through accidental ignitions, as diverse as errant cigarette butts or power tools or house fires that spread into the vegetation, or in this case, it's rumored to be down power lines, which again, I don't have any way of confirming, but certainly would seem plausible given where the fire started and the conditions under which it started. It ultimately doesn't really matter what sparks started the fire, because given a spark, these were extreme burning conditions, and we unfortunately saw what happened there. But the reality is that Hawaii, especially the western slopes of the more mountainous islands, are potentially quite fire-prone regions. There are wildfires every year on the Hawaiian Islands, just as there is significant snowfall every year at the peak of the very tall volcanoes on Hawaii every year. Those are both statistics that I know always surprise at dinner parties, but that's the reality of this part of the world that a lot of folks aren't necessarily aware of, and there are people who study wildfire in Hawaii because of that. And so, this has taken a lot of folks by surprise. Certainly, I don't think there's ever been a wildfire disaster on the scale in the Hawaiian Islands. I think that's safe to say already. In fact, the governor has claimed that this is probably the worst disaster anywhere in Hawaii since Hurricane Iniki. And honestly, it may end up being worse than that, depending on how this goes. So this is a major disaster for Hawaii. All of this is, of course, complicated by the fact that Hawaii is not California in the sense that it does not have a large, dedicated wildland firefighting state agency. So, there aren't dozens of slurry-dropping aircrafts and dozens of helicopters and many hundreds of fire engines and thousands of firefighters available to fight a fire like this, especially on Maui. There isn't a huge population on the island of Maui. It wasn't even close. And there's limited air support that exists in the Hawaiian Islands generally. I think it may be limited to helicopter drops. I'm not 100% sure about that, but there is not much you can do in the dead of night when there are 60-mile-an-hour winds anyway. We've already experienced that even in California, which does have access to tremendous, probably the best wildland firefighting resources in the world. Sometimes, under the most extreme conditions, there just isn't a lot you can do. I think the real tragedy of this event already appears to be the fact that there was not time for an orderly evacuation, and there may not have even been an evacuation plan So I think, and there's a lot of tourists in that area too. I think the ratio of permanent residents to tourists this time of year is probably low. There are a lot of tourists who may not have had access to personal vehicles, may not have known the local road network, nor where to flee to in this probably very unexpected disaster that unfolded. So, that's some of the context here. There's some headlines saying a hurricane caused the fire. I mean, it's possible that the downslope winds ignited the fire via a power line or something. I don't think it makes sense to say a hurricane caused the fire, partly because the winds were not only generated by the hurricane, but it's sort of indirectly via this interaction between the hurricane periphery and this high-pressure system. But that is an interesting mechanism. There have been reports in Southern California of the rare near-shore tropical cyclones in a few cases causing downslope windstorms. I don't know of any examples where they fueled catastrophic fires, but this is something that happened as recently as a couple of years ago. Fortunately, it wasn't a huge problem because the rain started pretty shortly thereafter. But this is an extreme downslope windstorm, and critically have it at an unusual time of year, potentially in summer or early autumn in Southern California. And it wouldn't really be a traditional Santa Ana, but it would be induced by the pressure gradient at the periphery of a hurricane like this. So some food for thought about California. I wouldn't worry too much about it. We get plenty of downslope windstorms on an average year that don't have anything to do with hurricanes. But it is something interesting to think about, that sometimes unusual combination of events can produce very unexpected outcomes. And it is fair to say that, at least indirectly, that this hurricane south of Hawaii may have contributed to what will probably be the worst wildfire disaster and potentially one of the worst disasters, period, in the history of the state of Hawaii. So this is another sobering event, and there's footage that I'm not sharing on social media because it is extremely graphic. Unfortunately, on Twitter, that's seems to be perfectly acceptable these days. And it's also gotten a lot more difficult to vet footage. Some people are sharing footage from Greece and saying it was Hawaii, footage from Canada, and even from California in recent years and saying it's Hawaii. So it's actually getting very difficult to discern which footage is legitimate. So I'm trying to be judicious in what I share for that reason as well. What a mess all around. I think another thing this illustrates is that we're so used to hearing about wildfire risk in California and maybe Colorado or, up in Canada now increasingly we're seeing these extreme fires this summer. Canada continues to see a wildfire season that's obliterating all records for Canadian fires. I mean, we're like doubling and tripling the previous record value of like almost all statistics that I've seen. But this goes to illustrate, I think, two things. One is that there are a lot more ecosystems and therefore populated areas in the world that are potentially, or at least conditionally, at risk of wildfires and of potentially catastrophic urban interface fires subsequently, then I think meets the eye. And I think this unfolding tragedy on Maui is an example of that. But there are other regions that perhaps are maybe even more surprising. And I and a lot of other people who study fires and extreme weather and natural hazards in general would not be tremendously surprised in the coming years to see a wildfire catastrophe unfold in New Jersey, in the Pine Barrens, or even along some of the coastal areas there, where the Pine Barrens meet these coastal resort towns. I wouldn't be surprised to see something happen in the Blue Ridge Mountains, say in western North Carolina, or in the upper Midwest. You never know what kind of forest fire might emerge during a high wind event during a drought in the Upper Peninsula of Michigan or in northern Wisconsin. All of these places are places where there was historically an extensive history of fires, but a more sporadic one. Unlike California, there's fires every year. Even in a mild year, there's still many fires. And this is so far been a relatively mild fire season in California, and yet there's still been a number of fires that have made the news. That is not true in some of these other places I just mentioned that are conditionally at high risk. of fires. It does not mean that they see lots of fires or necessarily that they're going to see more fires all the time, but it means that under the most extreme conditions, so under the driest, hottest conditions, well, we're expecting those to become drier and hotter. So when you get those conditions and they align, the likelihood of seeing these extreme fire events in places that are kind of surprising, I think, is going up. And we've seen that recently in parts of Central and Northern Europe. Southern Europe and the Mediterranean, no stranger to fire. There's a long history of even destructive fires in places like Greece, and even parts of Italy, as well as Northern Africa in the mountains there as well. But we've now seen not only an intensification of that in the fire-prone regions in the Mediterranean, but also a real expansion in recent years of destructive fires into even Western and Central Europe and Northern Europe in some cases. So, and again, these are places where ultimately serve as a reminder that there are a few things that matter. And really, what you need to have a wildfire, of course, is potentially flammable vegetation. It turns out that any vegetation is potentially flammable, whether it's a tropical rainforest or a savanna or sparse Joshua trees in a desert. But what you need is an ignition source, and frankly, those are so easy to come by naturally and human-caused. There's always sparks out there, so the question really is what happens next. What you then need is the vegetation to be dry enough to sustain a flame, and the drier it is, the more intense and the larger and the more potentially dangerous those fires are going to tend to become. And so really, even in a place like a tropical rainforest, we've heard about these Amazon rainforest wildfires in recent years, right? That may sound weird to have fires in a tropical rainforest, but there again, you don't get them every year or even most of the time. But if you have a drought and if it dries out in the tropical rainforest, there's a ton of potentially flammable vegetation. And we're seeing I hesitate to call novel emergence of wildfire in these regions, because sometimes it's a reemergence of something that happened prior to modern contemporary human history, but sometimes it's a return to something that happened only thousands of years ago, well before we had cities and highly populated regions that intersect these potentially high-risk zones. So we're talking about the emergence of new fire regimes, certainly fire regimes that we haven't seen in centuries, in kind of unusual places like the tropics and the Arctic, as well as an amplification of wildfires in places where we would already expect to see them in the subtropics, so California and the Mediterranean and southeastern Australia, places like that. And so, climate change is not the only factor at play, although even in Hawaii, there's already a number of research studies suggesting that indeed, as with California and many other fire-prone regions, climate change is increasing the risks. So, as always, I'll caution folks that it doesn't make sense to ask the question of, did climate change cause this fire catastrophe? But the answer is no, but then nothing else singularly did either. So it just isn't a well-posed question. The question of, are there links between increasing wildfire risks in Hawaii as there are in most other fire-prone or conditionally fire-prone regions globally? And the answer is yes, that evidence does exist. Is it the only thing that matters? No, absolutely not. And I think this is a clear case where the fire that was so destructive on Maui may not even be that large in the broader scheme of things, maybe just a couple thousand acres. So potentially not too dissimilar from the Oakland Hills fire, which again, back in 1991 in California, wasn't an enormous wildfire, really. It was only a couple thousand acres. I mean, we're now seeing 500,000 acre, million acre wildfires out there. So that wasn't what was extraordinary about it. But the problem was almost the entirety of that multi-thousand acre footprint was in a highly populated area. And so that included numerous structures that were occupied by people at the time, much as the Oakland Hills fire did, and other fires in more contemporary settings. The difference is a lot of the fires we've seen in California recently that have been incredibly destructive were also very large. That isn't necessarily always going to be the case. The Oakland Hills fire is an example of that, and this fire in Hawaii, an example of that. Another recent example, closer to where I currently live in Boulder, Colorado, was the Marshall fire in Colorado a couple years back, which destroyed thousands of structures and killed a few people, despite only being a couple thousand acres or a few thousand acres large. So Size is definitely not the only thing that matters. The human footprint of populated areas is critical. There are a lot of people potentially living in harm's way. How are communities designed? How are buildings designed? It sounds like, unfortunately, on Maui, there were a lot of old exposed wood structures. So once fire got going in a few of them, it just spread, I would say like wildfire, but it actually spread more intensively than a true wildfire, because it turns out that burning structures generate these enormous ember storms. There's actually more embers generated when you're burning structures that get borne by the wind and blown into the next structure than there would be if it was just brush and trees burning. There's some recent research that suggests that that's often the case during these catastrophic urban conflagrations that start out as wildfires and become arguably something else. I posed this in a perspective piece I wrote for The Guardian in the wake of the Marshall Fire a couple years ago, that we're sort of seeing, in some ways, the reemergence of the urban fire catastrophe. This was something that what's old is new again in some ways, I think, and there are fire historians, I think, who can speak more eloquently than I can, certainly more quantitatively than I can on this. But my point really is that, for centuries prior to the advent of modern firefighting, whole big cities would burn down, not because of wildfires, but just because of someone knocked over an oil lamp in a wood building, and it just spread building to building and then block to block. Before you know it, the whole city has burned down because buildings, there were no fire codes, there wasn't really firefighting, there weren't firefighters, vehicles, equipment, so there wasn't much you could do. If a fire started in a multi-story wooden building in a big city on a dry windy day, it might just spread throughout the rest of the city. And there were great fires in London, in Chicago, and then ignited by, in the wake of earthquakes, when water supplies were cut off, of course, in San Francisco in 1906, and also in the 20th century, to a certain extent later in the 19th century. Looks like I'm frozen a minute there, so I'm going to come back. Still got to fix that. But it looks like... sorry, let me rephrase that since I was freezing for a moment. We started to get better at fighting urban fires when fire codes developed, and then urban firefighting tactics developed. There were originally horse-drawn pumps with hoses. Once cities got potable water supplies and pipes, then it was easier to get water access. Fire engines, modern firefighting. So there were both equipment, technological advances, and then public policy advances in terms of fire codes, and then also strategic advances in terms of actual firefighting strategy that largely led to the end of these major urban conflagrations in most settings in the 20th century, with, of course, the massive exception of wartime events. World War II, there were fire bombings, and of course there were the nuclear weapons that were used on Japan and created much of the damage from those bombs. Actually was the ensuing firestorms. But aside from wartime, we pretty much got rid of the threat of widespread urban conflagrations later in the 20th century, and now looks like they've started to reemerge. We're not seeing them necessarily in the dense urban core of large cities. It's not that we're seeing skyscrapers burning in wildfires or anything, but we're seeing wildfires make greater and greater incursions into populated areas, including places that were genuinely surprising. For example, the suburbs of Santa Rosa, Fountain Grove, during the Tubbs Fire. Everyone knew that Paradise was at high risk of fire, but most folks thought that it was the fringes of the town, at the edges, that were probably at most risk, and then essentially the whole town burned to the ground. In Colorado, the Marshall Fire burned just through suburban environments, even through shopping malls, through the Costco parking lot. It jumped the 8-lane freeway and just started burning structure to structure, dry lawn to dry lawn, and front yard tree to front yard tree. So at that point, fence to fence, is it really a wildfire anymore? It started out as one, much as these other events did. But what did it become ultimately? And the dynamics are different. The dynamics of fighting urban fires are different. The tactics are different. the compounds that are burning are different. You get these ember storms when structures burn. There's lots of toxic chemicals when structures combust. Think of all the things, not just in the building materials themselves, but in all the other things we have in our homes, vehicles with gasoline, paint thinner, any number of potentially hazardous chemicals that burn. When at least you have a forest fire, it's not good to breathe in any kind of fine particulate matter in the form of smoke, but you sort of know what you're dealing with if it's bushes and trees and grass burning. But what about when it's going through homes? It's, any substance known to man potentially that's in that smoke plume, which makes it all the more complicated. So I think it's just, unfortunately, another example of what we're seeing. And of course, it's not only a climate change question. There is a climate change component behind, the escalating wildfire crisis, as I think some folks have termed it, and I think that's a fair use of the term. The other aspects are that there's more and more people living in harm's way, and in many cases, we do have the legacy of land management and forest management policies where we excluded beneficial natural fires and indigenous burning from the landscape for a century or so, or we made other bad decisions about how to manage land that resulted in more fuel for the fires. But then we have climate change coming along and kiln drying that extra fuel that was the result of other human decisions, and then public policy decisions are such that we've decided to allow lots of people to move into these high-risk zones. So we've added more fuel to the fire, kiln dried the fuel with climate change, and then lots of people have moved into the kiln. Not a great combination. And it's an example of the complexity of what's going on. And I just wanted to emphasize that lots of folks will say, climate change caused this, or climate change didn't cause this, it was forest management policies, or no, it wasn't forest management, it was the expansion of the urban footprint. There's just more people living in harm's way, and so that's why we're seeing more fire losses. And the answer is that this is a rare case where everybody is correct in a certain sense. It is all of these things. None of these things are unimportant. But the reality is you can't say that it's just any one thing. And in different events, in different regions, in different ecosystems, one of those three factors can be more important than others. In some cases, it maybe is mainly a climate change question. In other cases, maybe it is mainly a land management or a public policy, urban interface expansion question. But the reality is, the urban interface is only relevant in some places. Forest management is only relevant in forests at a minimum, and only in a subset of forests at that. But climate change is happening everywhere. And I think this is the challenge, is that climate change is acting as this risk multiplier on top of these other factors that are changing. And we often, we see headlines that boil this down and oversimplify. And I know that you need to have simple headlines. I know that we need to be able to give sound bites. But the reality is this is a complex issue, and there isn't a singular cause. There isn't a singular explanation for why the wildfire situation has escalated and why we're seeing so many events of a magnitude that we just didn't see before. It isn't just any one thing. It's all of the above. And yes, climate change is part of it, but it certainly isn't the only factor at play. So I hope this is the last time this season that I have occasion to report on one of these events. There have been similar events in Southern Europe and the Mediterranean this summer, catastrophic fires that left people scrambling, even running to the beach. There's some eerie parallels to what happened on some of the Greek islands earlier this summer. I don't cover all of them because I have a limited amount of time and geographic scope, but I did want to focus on this one because this is something that happened in the United States, in a place that people don't normally expect. And I know there's going to be a lot of questions about how this happened in Hawaii, the mechanisms at play, and the context. So hopefully that provides some context. Again, I'm not an expert in Hawaiian fire, and I hope that folks in the media will defer to those who are, especially if I'm wrong on one of these points. But I did want to give a broad overview because there seems to be a real vacuum of information out there right now. And I think it's interesting to compare and contrast, and important to compare and contrast some of the hazards that happened, that unfolded, and the background setting, and also the societal response, to the disaster. Unfortunately, this was yet another catastrophe where there was no flow of information. People did not know that there was a fire initially. They didn't know where it was coming from, where it was going, where they should go. There was no communication. And we just see this time and time and time again. And I just say that there's all these folks in Silicon Valley. I don't think that's the right application of technology in the wildfire space, where I think it could make a huge difference. And I want to pause a moment since I know I froze, and I really want to make this clear to everybody who's listening. Where I think that technology really could make a big difference is with the flow of information, real-time data acquisition and dissemination, understanding these disasters minute by minute as they unfold and making that information readily available to people. This is yet another example. Like this, it's incredibly, it's kind of depressing actually that this has happened yet again in another state, and there still was something that people didn't have any way of getting real-time information, and it's very possible that people died as a result of that again. So this happens over and over and over again. We haven't made much progress. It's a little bit better than it used to be in California, but under really extreme conditions, I'm still not sure that we'd have enough information out there. And Twitter has become an unreliable source. This is actually, unfortunately, quite a good example. There's a lot of misinformation. There's a lot of people misusing hashtags and posting fake information and videos from other fires at other times. So even I'm struggling to get the inside scoop on a lot of this. The news media is, unfortunately still really behind. But social media is not a reliable source either. So where do we turn to? I really hope that the tech world thinks about a way to address this, because this is actually a problem, I think. Not every problem is amenable to a technological solution, but I think that aspect of it probably is. So if anyone has wants to have a conversation about that, let me know. Happy to chat. All right, so I'll move on from that for now, and then I'm going to return to it to answer questions that have come up. Since I have not been monitoring the chat, I'm going to go through it at the end. So you know what? Actually, I think what I'm going to do is I'm going to go through any wildfire. Now I'm going to scroll back up. All right, well, I do have some additional complaints about the tech setup. Yes, I'm aware. You can hear the computer fan. I know there's been some cutouts in the processor. It's not the internet speed at this point. My 2018 MacBook is just not cutting it. I think I need to find the budget for a new machine for audio and video streaming, so hopefully you'll see the benefit when I can come to terms with the price of a new MacBook. So stay tuned for that. I think that's part of the problem here. So technologically, thanks for sticking with it. I know there's some problems. They will improve, I promise, the fan noise and the interruptions. But for now, thanks for thinking. Yes, lots of questions about the fan. Pausing a moment to let the computer, yeah, okay, the feed is back up. Yeah, again, I apologize. A comment from George that reminded him precisely of the Marshall Fire, a quick transition from a brush and grass fire to an urban conflagration within a downslope wind event. Yes, I agree. There are a lot of parallels. The Front Range of the Rocky Mountains in Colorado and the leeward side of Maui are, of course, are radically different climate conditions, and yet they do share these similarities, this propensity for downslope enhanced windstorms that can become very dry, and the presence of a sharp transition from lusher forests at higher elevations to brush that can potentially dry out quite dramatically at lower elevations, with population center immediately adjacent to the dry brush. So yes, I agree that there are structural similarities there, as I mentioned earlier as well. Brian asks, this is only indirectly related to Maui, but after the Maui discussion, do you have any thoughts on the predicted dry lightning event for Northern California this weekend and next week, comparison to August 2020? Again, August 2020 was exceptional not only because there was a tremendous amount of lightning across a broad region, but also because it had been exceptionally hot and record dry leading up to it. So folks keep, I think, forgetting how important antecedent vegetation conditions are. It really matters if it's just ordinary dry for summer in California or if it's exceptionally dry. And this year it is not exceptionally dry. We had a really wet winter and an unusually cool spring that followed. So generally speaking, yes, there is a risk of wildfire. Yes, there could be some lightning this weekend. No, I don't think it's likely to look anything like August 2020 for really either of the reasons that August 2020 was exceptional, which is to say it's unlikely there will be as much dry lightning over as broad of a region as August 2020, and it's not nearly as dry in places as it was then. Is it still possible we'll see some lightning-ignited wildfires this weekend or early next week? Yes, it's possible, even probable. Will it be a huge problem? Right now, I don't know. It will be followed by a heat wave, which always gives us a little bit of pause because it allows small remote ignitions to get cooking as things warm up and dry out. I do want to take a closer look at the weather models in a day or so. I've been so busy I haven't had a lot of time to look at them. So if this looks like a major threat, I'll definitely have a blog post and might also have another live office hours session in that window to discuss it. So stay tuned. It does look like there could be some risk of wildfire ignited by lightning over the next week, along with a heat wave to follow, but I'm not currently expecting an exceptional event. So, but stay tuned since I need to take a closer look. Here. Event next week, but I actually haven't looked closely enough at it to give any details, so stay tuned. Yes, I know the connection is wonky. Again, if anyone has any tech folks, video streamers have ideas as to how to improve the situation the first time, I think it's mainly just that my processor isn't capable of running the software that's needed to stream live, but we'll see. Actually, while I'm thinking about it, I'm gonna take a quick look at the there's no drop frames. It's a low CPU usage, so it's not that. Anyway, sorry for the tech talk. Just trying to troubleshoot. It's easier to do it when you're live. Some folks are remarking about the similarity to, or the dissimilarity to urban conflagrations in history in places like Chicago and London and San Francisco and Portugal. So, yes, I did mention that. More questions about next week. Yeah, again, for folks, especially for journalists who are asking these questions about next week, I just don't have enough information yet because I've been so busy. So stay tuned. Either tomorrow or Friday, I should have something to say about that. The more if you don't hear from me on Thursday or Friday, I'm not that worried about it. So no news is, if not good news, at least better news. So we'll see. Thanks for the this is an epic educational rant. I'll take that as a pretty nice compliment. I do get to do that. Sometimes it's fun to be able to have a bit of a monologue and stream of consciousness in this setting, since I know it's a pretty engaged audience. I mean, I know I never am able to respond to everybody's questions and comments. That's just not the nature of there just isn't enough time. But I don't know if it's the YouTube content moderation filter or what, but it's a remarkably on topic and focused and constructive conversation in the comments here, so I really do appreciate that. I was not sure that was going to be the case when I started having these conversations, and it really has been, so that's very encouraging. A comment from Philip that hardening communication infrastructure, even if the physical infrastructure for telecommunications during these events is disrupted by these events. Oh boy. Yeah, I know I'm cutting out a lot here. All right, sorry. All right, this is going to be a priority if anybody has any advice to fix this feed. I think that in addition to hardening the actual telecommunications infrastructure, there needs to be the human interface of that infrastructure needs to be dramatically improved, because right now I'm not sure that the situation in Maui, for example, would have been any better if the cell networks hadn't gone down, because where would people have gotten that information? There was no real knowledge of where the fire was in the moment or where to go. I think there needs to be a really rapid There needs to be a form. So it's both a technological problem at a very basic level. Like if the cell towers catch on fire, if the power lines fall down, then you don't have electricity and you don't have telecommunications. That's a problem. Then you can't really get stuff out at all. But then there's also the question of, even if that didn't happen, all the power stayed on and all of the cell phone towers were working fine, what information would you disseminate and how do you get it out quickly enough to the people who need to know it and in a simple enough to understand format? I mean, I know that there are weather and fire geeks who know which hashtags to search on Twitter. That's not an effective emergency or disaster communication mechanism, like by any means. It needs to be frictionless, almost immediate, and broadly accessible. You don't need to have a specific social media account. There needs to be a better way, and I'm convinced that there is a better way, but we haven't put it into practice yet at scale. So again, if anyone in the tech world is interested in this problem, I'm happy to participate in helping to address this. Alrighty here. Continuing to go down. Oh yeah, a few folks suggesting that, mentioning that they have received my extreme weather calendar. I guess the pre-order shipped. So hopefully you enjoy it. You can now just regular order it and it will show up quickly. So rather than pre-ordering, there's also going to be at least one more calendar year to follow. So some new content for next year too. I'll try and post a link again if you're interested once I upload this video. Yeah, as Paul mentions, there is a lot of real-time geospatial data with respect to wildfires that is available. So satellite imagery, I would add radar imagery, and even live camera imagery. Maybe even crowdsourced social media imagery, although that's gotten hard to, that's a little bit harder to make sure you're not being fooled by misinformation. But for those objective sources, these remote sensing platforms, satellites, planes, and stuff, as well as just basic cameras and weather radar, there should be a way to integrate this more rapidly and more systematically. And so, there is actually a push at the federal level right now. I recently had some conversations with congressional staffers about efforts to consolidate some of the fire weather operations within NOAA and the National Weather Service, and they are doing some hiring now. I don't know if the federal legislation that will authorize new funding for this will be successful or not. I actually don't know the details right now. Again, it's been an extremely busy month, but that may be starting to happen inside NOAA, but I still think there's going to be a gap between the public emergency near real time or real time emergency communication side of things and the actual provision of that data through an accessible means that almost anybody can access in real time. I still continue to think that is at least as much a tech interface problem, human interface problem, as it is a scientific problem. It is both, but I think that the latter one is the bigger part of it and potentially maybe is, I wouldn't say easier to address, but more addressable maybe by the private sector and the tech sector generally. All right. Let's see here. Oh, that's interesting to know about Zeke Lunder's live streams. Yeah, maybe the solution is just a new computer. All right, well, I'll have to look into that a little more seriously. Let's see here. All right, so I think I've gotten to the end of the wildfire-related questions I wanted to ask. I did mention, and I know this is going to be a slightly longer than hour session, so office hour and some bonus minutes maybe. I'll try and make this part a little bit shorter than the first segment. Wait for my new monologue on a different topic, and then I'll answer as many questions as I can afterward before signing off. Starting to lose my voice a bit, so more cold tea. So I did want to reflect on a lot of rumors that are circulating, especially on social media, surprise, surprise, but also in more mainstream media right now, about the degree to which the very unusual tropical oceanic volcanic eruption, the Hunga-Tonga eruption last year, has affected global climate, particularly in the context of seemingly countless record-shattering heat extremes over land and sea and extreme rainfall events this summer as well. And also how a recent relatively sudden, over the course of a couple years, decrease in the aerosol pollution, so the soot essentially emitted by ocean-going ships as a result of new pollution regulations globally that occurred beginning in about 2020. And I previously had a session devoted exclusively to this. I talked about how both of these things could potentially result in at least some additional increment of warming in the short to medium term, at least in some regions globally, that would add to the much larger increment of human-caused climate change through the accumulation of greenhouse gases in the atmosphere. And that it wasn't totally clear at that point what the magnitude of the effect of that Hunga-Tonga volcanic eruption or potentially those decreasing aerosols would be. And I just want to summarize, there's been a lot of people working on this scientifically quite rapidly over the past few months, and there's now a lot more quantitative evidence to make a claim, which is, and I'll go into this a little bit, but the long story short is that the effects appear to be very small of both the net warming of the sulfur aerosol emission reductions from ships. Not zero, and it's plausible that both of them are in fact warming the climate beyond what we would have expected otherwise, but the increment is the key part. Is this a meaningful amount of additional warming, or is it a trivial amount? I'm not quite willing to say that it's trivial, because at this point, every fraction of a degree centigrade of global warming matters. But it is small, certainly, in comparison to the global warming that's just caused by the regular old traditional means of emitting greenhouse gases and having those accumulate in the atmosphere. Well, let me quickly explain the different mechanisms. We've seen about 1.2, and as of the summer with the record-breaking heat, maybe more like 1.3 degrees centigrade of global mean warming. We've seen individual months above 1.5 degrees of mean warming, but if you average over years and all calendar months, it's still under 1.5 degrees, but less so than it used to be. So we're probably up at about 1.3, maybe 1.35 degrees centigrade global warming. And that's caused almost exclusively by the accumulation of greenhouse gases in the atmosphere, which essentially allow the Earth to retain more of the energy that it's trying to radiate out to space. So the increasing thickness of that greenhouse gas blanket allows the Earth to retain a relatively modest but hugely significant additional fraction of that outgoing long-wave radiation. So the Earth radiates to space because it has a temperature above 0 degrees Kelvin, and it radiates primarily based on its temperature in the long-wave spectrum. So sunlight is shortwave radiation. The Earth, of course, is not as hot as the sun, so it's not radiating visible light. You can't actually see it. It's radiating much lower energy, longer wavelength, long-wave energy. And as the blanket of greenhouse gases becomes incrementally thicker on Earth, incrementally more of that energy becomes trapped in the system, because those greenhouse gases absorb an increasingly large fraction of that outgoing long-wave radiation, and that results in a net warming effect on Earth, because there is an increasing imbalance between the energy coming in from the sun and the energy leaving the Earth to go back out to space. It may not feel like a lot, but as that balance grows, remember, it's a cumulative effect, so that energy starts to accumulate. The Earth is warmer than it would be with a slightly weaker greenhouse effect. That's how global warming works in a nutshell. Hunga-Tonga, the volcano, was an undersea volcano in the tropics that injected a record-breaking amount of water vapor into the stratosphere, water vapor is a greenhouse gas, much like CO2, except that the key here is that Hunga-Tonga injected that water vapor to extremely high levels of the atmosphere, well through the troposphere, into the stratosphere, and even apparently into the mesosphere, above the stratosphere. That is an exceptionally powerful volcanic eruption. It is incredible that the plume from that volcano managed to put water vapor above the stratosphere. And the reason why it matters is typically there's very little water vapor in the stratosphere. So in absolute terms, in terms of like total mass of water in kilograms that this volcano put up in the stratosphere, it's not a huge amount. But in relative terms, because there was so little to begin with in the stratosphere, it might have increased stratospheric water vapor by almost 10%. So that's not small. That's a pretty significant jump. And the reason why that matters is water vapor in the stratosphere can slightly warm the Earth. And the impact of injecting, if you had injected the same quantity of water vapor into the troposphere, it would have been completely negligible because there's already tons of water in the troposphere. So it would have been just this negligible effect. That's why most undersea eruptions, they put a bunch of water into the atmosphere that's already got a bunch of water in it and it rains out. No big deal. But a lot of this water vapor got injected into the stratosphere where it's going to stay for a long time and where proportionally it's a much larger fraction of what's up there. And so the hypothesis was that this might actually warm the Earth for 1 to 5 years by a measurable amount. And that still appears to be true, but the amount is becoming more clear, and it's very likely to be less than 0.05 degrees centigrade. And again, that's not totally negligible given that we're really worried about 1.3 degrees of global mean warming, 1.4 degrees of global mean warming. 0.05 degrees centigrade is, as I mentioned, small, quite small relative to the total warming, but not totally negligible. So it probably is contributing a little bit, but we're talking about a pretty tiny fraction of the degree of warmth we're seeing this year. And also, it's not permanent. It may last for a few years, but eventually the effect of this extra water vapor in the stratosphere is going to go away. So we'll lose that 0.03 to 0.05 degrees centigrade of global mean warming in a few years from now. We won't notice it though, because the Earth will have warmed by even more than that in the meantime from the human emission of greenhouse gases. So take that for perspective. When it comes to the ship aerosol conversation, the opposite effect essentially is occurring there, where historically for the 20th century, most ocean-going ships used very dirty fuel to burn in their engines for propulsion that generated a very large amount of sulfur aerosol pollution. Sulfur aerosol pollution, that's not a greenhouse gas. That has the opposite net effect. That tends to cool the Earth because it reflects sunlight. It prevents some of that sunlight from making it to the surface of the Earth. And that sunlight that doesn't get reflected, that doesn't make it to the surface of the Earth, is sunlight that doesn't get absorbed by the Earth and then doesn't get re-radiated as infrared radiation, which doesn't get trapped by greenhouse gases. So, long story short, if you emit a bunch of sulfur aerosols, you're going to cool the climate a little bit. Or, in the context of global warming, you're going to mask a portion of that global warming. Now, we've known about this masking effect of aerosols in the atmosphere for a long time. It's actually one of the reasons why the 20th century didn't warm more quickly than it did globally, because there was a whole lot of aerosol pollution globally, and it might also be a reason why we've seen a faster rate of warming recently. It's not necessarily because there's more the greenhouse gas forcing is accelerating so much as the amount of masking from these aerosols is decreasing. And so not only are we seeing the ongoing warming from increasing greenhouse gases, but we're seeing some of the warming that would have occurred previously being unmasked because there's less of these sulfur aerosols going around. And on some level, this is really, the sulfur aerosol decrease is good news because this is really terrible air pollution. This is stuff that you don't want to breathe. It's very toxic. It's not bad. So in that sense, it's not a bad thing. There's less of it. But what we're realizing is that it's unmasking some of the global warming that would have occurred up to this point, but was otherwise suppressed. There was a regulation change in 2020 that went into effect in 2020 regarding ship emissions, and that mandated significantly lower ship polluting levels that were allowed legally. And this was true globally. And so there was a bit of a sudden step change, a significant drop in the level of aerosol pollution coming from ships. This started around 2020 and has continued through the present. Over oceans, particularly over the primary shipping corridors in the major ocean basins. And the challenge here is that the quantity or the relative level of the suppression of warming that's coming just from ship aerosols is only a fraction of the total warming suppression that's coming from all aerosols. So there's lots of other aerosols. In fact, most global aerosol emissions were coming from factories and vehicles on land. So even though this was a very large decrease in ship aerosols specifically, ship aerosols are not the majority of total global aerosol emissions. So I'm getting a bit into the weeds here, but I just want to emphasize that yes, this was a sudden change in ship aerosol emissions, but ship aerosol emissions are not the only game in town, even when it comes to aerosols alone. There's a lot of other sources. So even though we saw a large decrease in ship aerosols, we did not see necessarily nearly as large a decrease in total aerosol masking suddenly in 2020. So long story short, there's new science coming out that's estimating that the effect of this is probably highly regional, so there may be a more significant effect in areas where there was a lot of ship traffic, which makes sense. That's where most of this aerosol pollution and masking was occurring, so locally your warming effect is probably larger than the global average. But the global average is probably under 0.1 degrees centigrade and potentially well under 0.1 degrees centigrade, potentially more on the order of the Hunga-Tonga eruption of about 0.03 to 0.05. So together, this may explain at the upper end up to about 0.1 degrees centigrade of global average warming, perhaps more than that locally in some places. That's plausible. But again, keep in mind that at this point, we're seeing global average temperatures that are 1.3, maybe even 1.4 degrees centigrade above what they used to be. So at most, it's 0.1 degrees out of well over 1 degree. So it's well under 10% of the increment of warming, probably under 5%. And again, the warming from the volcano, such as it is, very small, is temporary. That's going to go away. The warming that we're seeing as a result of aerosol unmasking is less temporary. Since it's not warming per se, it's just a removal of the cooling, the counterbalancing cooling effect. So that may stick with us. But of these two events that have gotten so much attention in the social media world, headlines asking, is this volcano responsible for the record-breaking heat this summer? The answer is no. Are these sulfur aerosol emissions from ships, is the decrease responsible for the record-breaking temperatures we're seeing this summer? The answer is no. It might have made them slightly higher, slightly more record-breaking than they would have been, but we're breaking records by such wide margins this summer that we probably still would have broken the records even if neither of those things had happened. So the number one thing that's happening, and this is going to come as a real shocker, based on the conversation we've just had, I say that sarcastically, is we're continuing to experience more and more global warming caused by the emission of greenhouse gases and their accumulation in the atmosphere. That's the number one factor by a mile, by 10 miles. And then we also have, in terms of global average temperatures, the developing El Nino event is starting to probably influence 0.1, 0.2 degrees of additional temperature increase, especially concentrated in the equatorial Pacific region. We oscillate between El Nino and La Nina, so of course El Nino-related warming is not permanent, just as La Nina-related global cooling is not permanent. But a lot of the mid-latitude and subtropical regions that have been experiencing record-breaking heat this year, those are not places that you would expect to see very hot summers during El Nino years. So we can't really invoke El Nino primarily either. And in the end, it really just comes down to, by far the dominant effect is human-caused climate change because of greenhouse gases. The next most important thing is probably El Nino, especially in some regions, the tropics, and some parts of the subtropics, more than others. And then, beyond that, in terms of order of relevance, perhaps things like the volcanic eruption and perhaps aerosol emissions are sort of there in a fairly distant third place collectively. And that's not to say that they're not important or that they're not interesting or that understanding them doesn't tell us something interesting and important about the world and the climate system that we live in. But it is to say that it's incredibly misleading to say, or to discount the fact that climate change has gotten us to where we are. It's not that suddenly this is this one-off weird thing that happened because of a weirdo volcano and some weird shipping regulation changes. I wish that were the case, because if it were the case, it would mean we didn't have a really big long-term problem. It would mean that this is largely going to go away soon. But since that's not true, unfortunately, we don't have that reassurance. And I just wanted to clarify all of this because I've seen some of these rumors get pretty out of control, and some of the headlines are kind of woeful in recent days. So I really just wanted to be absolutely crystal clear about what the science increasingly says. And I just want to remind folks, this is not really different than the conclusion that I came to last time we had this conversation, but I'm being a little bit more specific about the quantitative effects of the hypothesized role for that volcanic eruption and the injection of water vapor into the stratosphere, and likewise the shipping regulation change that decreased the sulfur aerosol masking load. That's essentially what I wanted to emphasize in that conversation. We just have more specific details now about what the science is starting to show about the relative magnitude of these effects. All right, so I want to take, I know I'm over the hour, so you're well into bonus territory now, but I do want to quickly look, take one more sip of tea, and then go down, see what questions there are regarding specifically the latter half of this monologue. So the volcano, climate change, and also the ship emissions stuff. Interesting, folks are reporting that the connection on their end, especially on their phone, is great. I am curious if anybody is experiencing the actual interruptions. So I know the fan noise is a bit of an issue. That's a separate problem. But if folks are seeing connections that get interrupted, the spinny wheel of death, or my audio cuts out, that is what I'm interested in. So if anybody has not seen any of that, let me know, because I see it on my end. I guess if people don't see it on their end, then it doesn't matter. So it would be helpful information. All right. Let's see here. Okay, this is not quite directly related, but I think it's an interesting question, and so I'm going to answer it anyway. A question about whether the fires burning in the boreal forests of Canada and Siberia, it is mainly Canada this year, but yes, on top of the fires from last year in the West, in the American West, and in Canada and in Siberia last year, the question is, are we losing carbon sequestration? And I think this is an interesting question. And I am neither an ecologist nor a fire scientist, but I work with lots of folks who are, and there's some pretty clear evidence that the forest fires we're seeing now, and I am being specific when I say forest fires in this context, because I am mainly talking about high-intensity fires in dense forested regions that are consuming not allowing them to grow back. Some forests are quite fire resilient, even fire dependent. They need fire. But we're talking about fires that are known as stand replacing fires that kill off a majority or even all of the trees in a given forest stand. So very high intensity events. And unfortunately, we are seeing more and more of those. And there's a lot of that happening in Canada this year. This is pretty bad news from a carbon perspective. Broadly, from a carbon market standpoint, this has caused huge problems because some of these fires up in Canada this year have burned through forests that were purchased to be carbon offsets by corporations, and the fires burn through them, and it's unlikely that those forests are going to come back in our lifetimes as forests that store nearly as much carbon as the mature forest did prior to the fire. So those carbon credits were essentially phantom credits, and this has been something that ecologists and fire scientists have been yelling from the rooftops about for a long time. Forest forest-based carbon offsets are not reliable because we may lose some of these forests. And there's both a net emission of carbon into the atmosphere from the fire itself. In one big pulse, you turn a lot of that organic matter into carbon in the atmosphere during an intense wildfire. But in an equilibrium system with natural fire regimes, you'd see regrowth of the forest that would quickly re-sequester a lot of carbon back out of the atmosphere as the trees regrew, since growing trees and expanding root systems is a great way to sequester a bunch of carbon. That's what's in the tissue of the trees. They're literally sucking it out of the atmosphere. The problem is, now in a warming climate, it's not just that we're seeing more intense fires and more extensive boreal forest fires, but also the environmental conditions following the fires are not conducive for those dense boreal forests to regrow as they were. So we're not getting to this equilibrium setting where in any given year some places burn and some places are regenerating and it's kind of a net wash. The problem is we're seeing places burn and we're not seeing those places regenerate, storing the same amount of carbon. And so I do think there's emerging, growing evidence now. There wasn't so much a decade or so ago, but now I think there's a lot of evidence that we're losing more carbon than we're gaining in a warming climate in a lot of these forest ecosystems, primarily because of wildfire. This was something I think that was somewhat underestimated. It's a major flaw in a lot of carbon credit plans. Why a lot of folks in the ecological world are skeptical of them is precisely for this reason. And also the long-term storage of carbon in these big tree stands that we once had. And it isn't happening everywhere, but it is happening in more places than the opposite is happening. So there are very few places where we're suddenly getting much rapid expansion of mature forests. We're seeing far more places where there's rapid diminution of carbon storage quality in these forests. And that's true not just in the boreal forests, but also in tropical rainforest. I mean, here is a place where deforestation is a big problem, but fire is becoming an increasingly big problem, and drought as well. So that's not a particularly good news story, but there's a lot of complexity there, so I didn't want to get too into the weeds because, again, I'm not an ecologist, but that seems to be what the research is suggesting at this point broadly. All right, here. Okay, so I guess people are reporting that, yes, you're seeing the same thing that I am in terms of the interruptions. All right, I got to deal with that, but I guess that confirms it, so thank you. All right, well, I think that there's lots of questions I wasn't able to get to, but only so many hours in the day. I'm going to work on developing a budget to buy a new streaming machine. I think I really do need that. I think this is really illustrating that it's not the internet connection. I don't think it's my external hardware. I think it's we don't design computers to last more than a few years these days for intensive use. So as much as I don't like to cycle through technology quickly, I think that's the answer here. Thank you again for joining, everybody. I know this was a long one. There was some heavy stuff. I will try and either have a blog post and or another YouTube live session later this week, maybe even this weekend, depending on how the timing works out, to discuss the upcoming potential lightning event in California, fire weather risks, and the heat wave to follow. And I hope folks. You never know who's directly affected by these disasters, and this is a genuine disaster. Folks who either lived on Maui or people who were vacationing there is probably a significant fraction of the people who were affected. That may even include some Weather Rest readers. So I'm hoping that everyone got out all right, but we know that's not the case for everybody, unfortunately. So just another one of those stories we've seen too many of in recent years. I hope that clarifies some things for folks about the volcano and the ship aerosols. And as always, join me for the next one. And do check out my extreme weather and climate calendar that's now available for quick shipping. You don't even have to pre-order it anymore. And there's also a 10% discount. I'll try and add that coupon code to the comments so folks can get it for a little bit less money anyway. All right.